Hello everybody, I'm Johannes. I'm from the Bavarian Environment Agency, which is sort of the geological survey of the state of Bavaria. It's one of the states in Germany in the very south, and we have a portion of the Alps within our territory, which means that we have to deal with landslides. And in my poster I'm trying to give you an overview of a case study we did at a slope at Maria Eck monastery, which is a monastery at one of the mountain ridges in the Bavarian Alps, and where we try to combine long-term tachymetric measurements on the slope movement with short-term or single ERT profiles, ERT measurements, and we try to reconstruct the sliding plane based on those combined measurements. So this is the setting. On the left-hand side you can see an aerial photo of the monastery. There are some buildings over there. They are lined along a mountain ridge with a supply road. And there is a main landslide body further down the slope to the north. We don't really monitor this one because it's not very active. It has been active, but lately it hasn't. But what is the more active portion is that slope right above it. And my colleague Thomas, you can see him there, he's a geodetic guy, and he's monitoring the slope movement based on a monitoring network he set up in 2009, and he's constantly following the movement of trees that are passively moved down the slope with the slope creeping process. And the origin of that was that in 2009 they found cracks in that supply road, in the tarmac of the supply road, and then also in the walls of that building where still like monastery people are living in there. And that's why it's an issue of the Geological Survey of Bavaria to keep an eye on that. On the right hand side you can see some ERT measurements we carried out in the past, some of them perpendicular to the main landslide body, and one of them we did this year is like following the dip of the slope, and then actually it's covering that portion of the slope between the main landslide body and that supply road that is affected by the slope movement. In my poster I will present you how we inverted that profile in two ways, one with after Loki and Barker with rest to the end, and also we tried to Barrett inversion, and we compare those results. And in the very end we are trying to reconstruct and model a sliding plane based on those results we picked from the ERT profile. So this is like an interpretation of a sliding plane in the lower portion of that profile, and by projecting it into a profile or a cross-section of the slope and combining it with that vectors that were derived from the annual measurements on the slope movement, we stepwise reconstruct the geometry of the sliding plane and more or less get an idea about a newly forming backscarp in that area, which turns out to be directly below that supply road. I'm happy to answer any of your questions at my poster. Thank you very much.